Okay, hi everyone. So let us finish off the rest of our tutorials. Please let me know if my previous video is alright. And yep, as a short here, please bear with us. It's a difficult situation at the moment. Okay, so in our previous video, we have looked at question 1 and question number 3. Okay, we are going to begin with question number 2, moving on for application question of 4, 5. Okay, question 6 and 7 are application question, which is very important for your Boyer-Morse algorithm, which you learn in week 2, right? So it's required for your good suffix rule. So let us begin with question number 2 first. Okay, so it's more of a question in regards for your understanding. Okay, when Z2 equals to Q, okay, then you will know the value of Z2, Z4, all the way up to Z2, right? Let me try to explain it. Given I have a swing, right, which is a very long swing. Okay, and then I also have a Z array which measures my swing, right? So here is the first position, which we know equals to the length of the swing. Okay, now what if for the second position the number is Q? What does it mean? Okay, so instead of Q, let me just put a number inside. Let's put 3. Right? So what you know is the 3 alphabets here will be the same as the alphabets here. Right? So if this is A, this will be A, this will be B, this will be B, this will be C, this will be C. Okay? But it's going to tell you something different, right? If you see here, if this is A, if the first letter is A and the second letter is A, it actually makes sense, right? So if Z2 equals to 3, therefore swing of 1 all the way to 3 equals to the swing of 2 all the way to 4, right? Which means swing 1 equals to swing 2, swing 2 equals to swing 3, swing 3 equals to swing 4, right? And I know swing 4 is not the same as swing 5. I mean, that's what your C box is. But if you observe here, 1 is the same as 2, 2 is the same as 3. Therefore, by transitivity, I can say 1 is also the same as 3. Likewise, if 3 is the same as 4 and 2 is the same as 3, by transitivity, I can say 2 equals to 4. But I also know 2 is equals to 3, right? And I know 1 equals to 2. In other words, if Z at position 2 equals to Q, we know the first swing from 1 all the way to Q plus 1, okay, equals to all the same character, right? I just got it character X. And then the Q plus Q swing, right, will not be the same as everything else. And it's the entire reason for your discussion of question number 2, as you see here, right? For any input, if we found that Z2 at position 2 equals to Q, then we know the 3rd, 4th, 5th, and 6th character instantly, right? And since Q plus Q is not the same as any other character, we automatically know the fifth character is also not the same as the third character, not the same as the second character, not the same as the first character, which means Z at Q plus Q equals to 0. Right? So in this scenario, let's say my string is, oops, my bad, I forgot to change it. Let me repeat again. If we know the fifth letter is not the same as the fourth letter, it means it's not the same as the third letter, second letter, or the first letter, which means the fifth letter is not the same as the first letter, and it's not the same as the prefix of the string, right? Which we can conclude Z of Q plus Q equals to 0. Okay? If you don't believe me, let's try the following. C array. Right. Okay. Let's say the value here is 4. Right? Remember, the first one is not important. So if we use position 1 and position 2 as the same letter, let me just write. Okay, it's 4. Right? Means the first two letter is the same, the second and the third letter is the same, third and fourth letter is the same, fourth and fifth letter is the same. Right? Here is where my Z box is. Right? Because you have a length of 4. But it will mean the fifth letter cannot be A anymore. And since the fifth letter cannot be A, which means the number here is 0. Right? And here is going to be 3, 2, 1, 0. Right? So it's actually one of the useful visualization. Okay? So if C Q equals to Q, therefore C3 equals to Q minus 1, C4 equals to Q minus 2, C5 equals to Q minus 3, all the way up to Q plus 1 equals to 1, and Q plus Q equals to 0. Okay, so here is my explanation for question number 2. As usual, if you have any questions, please post it onto Slack and I will try to respond to it as fast as possible. Okay, moving on to question number 4. Right, question number 4 and question number 5 is somewhat similar. Okay, let me explain the concept with alpha and beta. Let's say alpha is a string, right, and beta is another string. Okay, the entire concept about circular is if alpha and beta is circular. Okay, which means they are the same string, right, but the alphabet begins at different position. Let's say alpha is A, B, C, D, E. For beta to be circular, it can be B, C, D, E, A, C, D, E, A, B, D, E, A, B, C, right, and finally E, A, B, C, D. Okay, so the entire string which I've generated here is a circular of alpha. For example, if I were to visualize it, A, B, C, D, E, in a circular form, right? Beta can be B, C, D, E, A, or it can be C, D, E, A, B, right? Or it can be C, D, E, A, B, C, or it can be D. You understand the point. So I can actually visualize it as the following, right? Alpha equals to a string, let's call here the prefix, followed by another suffix. Right? And for pika to be circular, it's going to begin with the suffix followed by the prefix. So if here is A, B, C, D, E, F, and my pika is the circular B, C, D, E, F, A, you can see here is the, oops, let me just change the color. Right, here is a prefix, here is a suffix, right? And you're going to realize this is the prefix and this is the suffix. So how are you supposed to check if both strings are circular in O of n complexity? Okay, in the most naive version is, right, for example, you see here, you're going to try every combination, compare letter by letter, and if all of the letters are a match at different position, it means it's circular, right? If they are not a match, it means it's not circular. If I use all of the different alphabets, it's very, very easy, right? For example, here A, B, C, D, E, B and A is not the same, right? Then B and B is the same, C and C is the same, D and D, E and A and stuff, right? But if I give you A, B, and I ask you if A, B, A, C is circular, right? You're going to begin from here, compare. Wait. Right? Compare is not the same. Then I'm going to begin compare. Oops, not the same. And you're going to try a lot of comparison, which will give me O(n) squared. So what your question wants is actually, are you able to see if a string alpha is circular to beta in O of n? And how would you implement it? Okay, so if we were to try to exploit the entire prefix and suffix property again, we can actually perform the following: alpha, dollar, beta. Okay, remember alpha is suffix, alpha is prefix followed by suffix, and beta equals to suffix followed by prefix. If I were to concatenate beta with itself, it will be suffix, prefix, followed by suffix and prefix. Right? So if I were to do the following here, it's going to be prefix, suffix, dollar sign, suffix, prefix, suffix, prefix. And then I should be able to find my match over here. So it's just a very simple process of making, right, you taking picker, you duplicate it, concatenate it to alpha and dollar, running your C algorithm, which is in O of n. The moment you find a number here, right, when z at I equals to length of alpha, you have found out if it's a circular representation of alpha, right? If you never find the length of alpha, it means it is not a circular representation at all. So here is question number 4 answered. Right, question 4 answered. Now, moving on to question number 5. Right, instead of just circular, now you want a substring. Okay, now you just run a substring, which means if I see over here, if I were to use the same example again over here, if alpha is A, B, C, D, E, right? Beta can be the following: B, C, D. It can be B, C, D, E, right? Or it can be E, A, B. It can be D, E, A, B, and many forms, right? And the answer remain the same, right? You just go alpha, color, picker, run it as usual, right? Wait, my bad. I got confused. It is the opposite now. For example, picker is D, E, A, B, C, and alpha is probably B, C, D. Right? So my alpha is a shorter one. But if I were to do the entire prefix suffix again, the same as question number 4, I should be able to find it. Because it's the same concept, it's just my alpha is a shorter string. So I'm bound to find it eventually. Okay? But because we are in computer science, we want to be a little bit lazy. We do not want to include all of picker because it will be very, very, very long. Right? For example, if alpha in the example above is D, E, A, and my picker will be B, C, D, E, A. Yeah. Right? If I were to do alpha, color, picker, it will be D, E, A, color sign, A, B, C, D, E, A, B, C, D, E. And I should be able to find it over here. Right? This is what happens when you do the following. But you should be able to make an observation now. Because the string here is shorter, you do not need to expand it all the way. Right? So what you should be doing is alpha, dollar sign, picker, no choice. But for the second picker, you're going to go from 1 all the way up to length of alpha. So in this case, it's going to be DEA, dollar sign, A, B, C, D, E. Okay? And the last one, because the length is 3, I only require 3 alphabets more. Right? Because I know what I'm looking for is shorter. So I do not need all of my additional longer string. And in terms of application, the entire concept of circular is very useful when let me give an example. If you look at your DNA sequence, right, you have millions and billions of proteins. But when you slice your protein sequence, right, you are not going to slice it right at the beginning, right? You're going to slice it somewhere in the middle and somewhere longer. And since the sequence is always repeating itself, right, you're bound to come up with a circular case. So if I were to obtain a DNA sample and I want to perform a match, right, I can't really match it at the first position. I will try to look for some position which match, right? So in a real world scenario, when you're searching for something which is circular, such an approach is very, very useful, right? Compared to, let's say, you like to put force it for O(n) square, right? Versus now you can now obtain a solution in O of n. Okay, so we have already done question number 2, question number 4, and question number 6. Let us finish off with question number 2, 4, and 5. We are now finished off with question number 6 and question number 7. Okay, so in question number 6, you're given two string again, alpha and picker. Okay, so the string is not important. you're going to try to find the longest suffix of alpha. Remember, suffix come from the end, which matches the prefix of bigger, which comes from the front. So how are you going to figure it, or how are you going to find it if we're going to use a Z algorithm, right? So an easy way to see something is to always visualize it. Let's say here is A, B, C, D, E, A, right? E, F. And let's say here will be E, F, A, E, B, D. Okay, so here the longest will be E, F, and E, F. Another example, A, B, C, let's use the same one. A, B, C, D, E, F. Right, and here will be F, E, F, A, B, C. Right, the longest will only be F and F. So how can you make use of the Z algorithm to actually find it? Oops. What's happening? Give me a moment. Okay, nice. Okay. How can you use your Z algorithm for you to find it? Right. You already know if I have a Z array, the number, right, the number Z at K is the length of the substring, which is the same as the prefix. So we can see Baker is actually the prefix. So I can use Baker $alpha, and I should be able to find my number here. So for example, if I were to use the first set of example, E, F, A, E, B, D, right, $sign, A, B, C, D, E, F. If I were to fill out my Z, it will be not important. 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 2, 0. Right. And I know from the number here, right, my next two characters will be the same as my prefix. But because I am looking for suffix, right, I need to ensure the number 2, it will reach the end of the list, right? So if I were to say it will be I, right? So Z at I equals to 2, right? So Z of I, which is 2, plus I should be the length of my alpha. Okay, so if I were to say I, 1, 2, 3, 4, 5, 6, right? So Z of I is 2, I is 4, length will be 6. Because it needs to be suffix, it needs to reach the end of the string. In another example here, if I were to use my second example, F, E, F, A, B, C, $sign, A, B, C, D, E. Right, F. Right, not important. 0, 1, 0, 0, 0, $sign, 0, 0, 0, 0, 0, 1. Right, I will be 1, I 1, 2, 3, 4, 5, 6. Okay, Z at I is 1, I equals to, wait a minute, I equals to 6. Wait. I think I'm mistake. 1, 2, no. This is meant to be 5. My bad. Right, plus 1. Okay, my bad. Okay, so L will be the set of I plus I should be the length of alpha plus 1. I've forgotten because we begin from index of 1 instead of index of 0, right? So if I want to be consistent here again, right? Length of alpha equals to 6. Therefore, set plus I should be equals to length of alpha plus 1, which is 1 plus 6 equals to 6 plus 1, 7 equals to 7. Okay, one last and final example here, right? Assuming alpha is A, B, C, D, E, F. My beaker is going to be, let me just change a bit. Okay, let's put alpha as A, E, F, E, F, A, F. Okay, and my beaker, let's say, is the same, F, E, F, A, B, C. So if I were to do alpha color beaker, right, I'm going to have the following. Beaker color alpha. So it'll be F, E, F, A, B, C, color sign, A, F, E, F, A, F. If I were to fill up my Z, not important, 0, 1, 0, 0, 0, 0, 0, 3, right? Because F, E, F, it should be 4, my bad, right? F, E, A, F is the same as F, E, A, F, okay? 4, then L should be 0, L should be 1 because F and F, okay? Then I have A which is 0 and F will be 1. So if I were to put in I, index 1, 2, 3, 4, 5, 6, I can see the Z of 2 is 4, Z of 4 is 1, and Z of 6 is 1. But I need to satisfy the relationship of Z I plus I equals to length of alpha plus 1. So in the first case, right, it will be 4 plus 2 equals to 6 plus 1. And you're going to realize it is not a match, right? Why? Because FEAF is not a suffix. It doesn't go to the end of the string. If I were to look at the second one as well, 1 plus 4, right, is still not the same as 6 plus 1, which is totally wrong, right? Because AF is not a suffix. So if I only look at F, it doesn't go to the end of the string. But if I were to look at the final one, 1 plus 6 equals to 6 plus 1. And you realize it is correct because F on its own is a suffix, right? So in other words, you're going to rely on the formula here to actually ensure it is a suffix, right? Because the question here asks for the suffix. Here. Which brings us to number 7, right? So number 7 is actually an extension of question number 6. Question number 6, you have two strings, alpha and picker. You want the longest suffix of alpha to be the same as the longest prefix of picker. Now in question number 7, you only have one string, which means your alpha is actually all of the combination from your string. So if I were to give you an example here, let's say my string is F, E, F, A, F, A, F, E, F. Okay, you're going to generate my picker is going to be the same as my string, but my alpha, I'm now going to have a lot of combination. The first suffix, the second suffix, the third suffix, fourth suffix, fifth suffix, and all the way. Is this part clear? Because if you read the question, right, the largest suffix from position I all the way up to n, right? So if you are going to take a string, you're going to cut it off. So you want to compute a length I, right? An annoying thing about Arun's notation is length I is not a function. Length I is actually an array, right? So you want to compute length I as an array. So if I were to come back here, length is actually an array, right? Which save the longest suffix of string from I to n, right? Which save the longest suffix from I to n. Okay, and I is where you slice it. It is actually an array. So if I were to look at my example here, F, E, F, A, F, A, F, E, F. One possible implementation is to reuse question number 6, right? But you're going to try different combination of alpha, right? And then save the number inside an array. So for example, here will be 1, right? Here will be 0, right? This will be 1. This will be 0, right? Because EF is not the same as F. Okay? But you want the longest, which means here should also be 1 because I still can reuse the portion above. So it will be 1. Then the next one will be FEF. FEF as a suffix is the same as my prefix of FEF, which is 3. Right? Then AFEF is not the same as FEFA, so I will put a 0. But I can still make use of the suffix, right? Because despite me beginning from A, I still have a suffix, right, which is FEF. So I know from earlier, FEF is actually 3. And now you should have realized something by now, right? If the value is 0, I will always copy the one on my right. Okay, so here is how you're going to answer it. F, E, F, A, F, A, F, E, F. I'm now going to build a Z array, right? So it's just like your normal Z algorithm. Okay, let me put a few numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, here will be 9. The first C array value is the same as the length. Here will be 0. Here will be 1 because F and F is the same. 0, 1, 0, 3, 0, 1. Right? It's just your normal Z array algorithm. Then I'm going to initialize the length array, which is what your question wants. Okay, and then I'm going to look at the number here, okay, and determine if length of, okay, if Z of I plus I equals to length of my string. Okay, is equals to the length of my string plus 1. So for the first one, 1 plus 9 equals to 9 plus 1, which is a pass. It will be a 1. The next one will be over here. Okay, 0 plus 8 is not the same. So I'm going to just copy the value over here, which is 1. Or if I were to be more specific, wherever I see a number of 0, just copy the 1 on the right. Right? Which is here the same. Next one. 3 plus 6 equals to 9. I pass. So I will put a 3. Right? And here will be 0. Oops. Right? And here it will be 0 plus 6. No, wait. My bad. Here should be 7. Right? Equals to 10. So the next one will be 0 plus 6, which is not the same as 10. So I will just copy the 1 on the right, which is 3. Okay, the next one will be 1. 1 plus 5. Okay, again my surface is eating up already. Okay, the next one will be over here. 1 plus 5 not equals to 10. Because it's not equals to 10, I just copy the value to the right. Copy the value, copy the value, copy the value. Here will be 9. Right? 9 plus 1 equals to 10. It will just be a 9. So by here, you have already generated your length array. Okay? So please do not be confused by the following, right? Harun's notation at times it uses brackets for arrays, right? It's not function. So if you look at your Boyer-Moore lecture, right, and you're going to see something called the good suffix, right? Your good suffix is actually an array. It's actually a good suffix array, which is very, very similar. Oops, my bad. I forgot to change again. Okay. So if you like a Boyer-Moore, there's something called a good suffix. It's lagging a lot now. Right? If you look at your Boyer-Moore lecture, there's something called a good suffix bracket. Looks like a function, but it is actually an array. And your good suffix array is very similar with how you calculate your length array. Okay? And it will not be discussed in your lecture slides for Boyer-Moore at all, because you're expected to know it from tutorial to question number 7. Right? So of all your entire tutorial, question number 3 is very important because it's how you've made an optimized C algorithm. And question number 7 is very important because you need it to generate your good suffix array for your Boyer-Moore algorithm in week 2. Okay, so that's all for me. All the best, good luck, have fun, and I see you next week or next week for the next video.